Hey guys, this is Unit 4, Video 5, which I've entitled Why Periodic. We're going to kind of go and start where we left off with Video 4. Let me pull it up here. Of course, it's not wanting to work. On page 14. So you guys should have completed page 13 as a review of what we went over. We're going to kind of pick back up, start talking about why the periodic table is called periodic in the first place. To kind of begin that, we want to kind of take a step back and kind of look at the overall structure of it. So I know we were in the last video talking about the arrangement. We talked about groups. We talked about periods. Make sure you familiarize yourselves with that vocabulary and start using it so that you know what those are referring to. Remember that groups can also be called families, and we kind of went through all of those. The next big thing I want to talk about is this thing called the staircase. And if you actually look in your reference table, I'm going to pull up the periodic table from that. I know we have gone through and kind of did this the last time. We drew on this one, the staircase in, and then if you see on table, your periodic table in your reference table, you have it right here. So they draw it in for you. That's kind of the separation piece that we kind of look at in terms of the periodic table. So staircase. Okay, metals make up most of the table. Now think about in here where it's orange on this particular periodic table, those are your transition metals. So don't overthink it. If you know where those are, you know that that side of the staircase, those have to be your metals. And then to the right of it are going to be your nonmetals, which we'll get to in just a minute. So again, they make up most of the table. They are left of or below the staircase, except for hydrogen. Remember, that's going to be the one that trips people up the most, and every year I see that over and over as they forget about hydrogen. So make sure you know that hydrogen is a nonmetal, even though it acts like a metal in terms of how it reacts. They are all solid state of matter at room temperature, except for mercury. Mercury is very, very cool. I wish we could, play around with it in school, but it's poisonous. They must have all four properties that we're about to list in terms of being a metal. So the first one is malleable. You probably, hopefully, have heard these terms before, probably in earth science, I would imagine. You guys probably went through and analyzed metals and substances for these. So malleable means it can be bendable, okay, hammered or molded. I want you to add the word bendable. That's the way I think of it. Number two, it's ductile. All right, so it can be drawn or pulled into a wire. They have good luster. Remember from earth science, luster means how shiny they are. Okay, and then they're good conductors, which this should not be anything new to you guys. Just think about wires that we plug things in with. All right, they got copper going through them. The reason why they're such good conductors is because of this piece right here. Star this. Make sure you know this. We'll come back to it when we talk about bonding in our next unit. But the reason why they're such great conductors is it's due to their sea of mobile electrons. All right, mobile valence electrons. Again, we'll talk more about that in our next unit on bonding. They like to lose their electrons and they form positive ions. Remember, what's a positive ion called? Cation. All right, so again, these terms that we've used. So metals are to the left. Nonmetals then are going to be to the right of the staircase or above. They're mostly gases and solids. There's one exception, which is bromine. Bromine and mercury are the only two liquids on the periodic table. They are not malleable. They are very, very brittle. All right, they shatter very easily. They lack luster, so they're very dull. They are non or very poor conductors. These are going to be your insulators. All right, they're good insulators, like silicon, for example. They like to gain their electrons to form negative ions. Remember, you should know what that term is. That's an anion. Okay, and they may have 1 or 0 properties of a metal. Then we got the metalloids. Okay, those are your semi-metals. They have properties of both. Okay, so typically 2 properties of a metal. They are along the staircase. There's one exception, is going to be aluminum, and they're between your metals and non-metals. Okay, so because of that, that kind of leads us into why is the periodic table so periodic, or why is it called that? Go through, answer these periodic table review worksheet, then come back and finish in your notes here. So why is the periodic table? Because, excuse me, as you move across a period, okay, you got a couple of things that are happening. You've got the nuclear charge. Again, this is something that people forget so often. Don't overthink it. The name says it all. Nuclear charge. It's the charge of the nucleus. It increases. That should not be anything brand new or, kind of mind-blowing to us, because think about it. You're adding a proton with every single element. So as you go from left to right, you're adding 1 proton. So think about it. You've got this massive positive charge. It's going to win what we call, if you think about a tug of war, between an additional electron. Because think, electrons are massless. Okay, they don't have any mass. So electrons are massless, and then protons are very massive. So think, you've got a 300-pound person versus a 50-pound, toddler. They're not going to win. All right, the toddler's not going to win. They're going to pull the electron cloud in more tightly. So it's going to go from out here, and it's going to get much closer together as you go from left to right. Okay. The second thing is, as you move from left to right, the number of energy levels doesn't increase either. Let me erase that. It stays the same. So there's no additional, orbits around it or shells around the nucleus, around the atom. So it's going to stay relatively the same size, again, allowing for that nuclear charge to go from here and start to pull in tighter. Think about 2 magnets, right? You've got positive and negative charges. They want to pull each other in. Opposites attract. Every element in the same period or row has the same number of kernel electrons as well. Okay, their valence shell are changing, but the kernel ones are staying the same. So you got a couple of different graphics there that can kind of help you understand that a little bit more. If you have questions, again, ask. Now, as we move down a group, okay, the nuclear charge increases. But the number of energy levels also increases. All right, so that means now you have an extra ring going around the nucleus as you go down. So this would say, this would be group 1. Group 2 is going to look something like this. Okay, so you start to get further and further away as you go down a group. All right, this leads to what we call shielding. Okay, increased shielding. What that means is you have more kernel electrons, which are negative, to interfere with the attraction between the protons and the valence electrons. Okay, so we'll talk more about the importance of this as we continue talking about the trends. Basically, guys, remember this right here. If the number of energy level increases, that's going to trump everything else. That's going to have the bigger impact on what we're going to see. And we're going to dive into this more as we start talking about the periodic trends in the next video.